Welcome to the Electronics 2 course. This is a first year, second semester course for the Higher National Diploma HND. And students, this is my first time teaching you. Sorry. As the name you find there, I'm called Linus Antonio Forejekum. And we're going to be looking at a couple of things in Electronics 2. I believe you studied Electronics 1, which was more of electronic devices, introduction to how they operate, and then some principles like Kirchhoff's law, Ohm's law, and all that. You also studied transistors and the types of transistors. So, this course is basically going to be assessed in this way. Your final exams, which you would take at the end of the course, is going to be graded 60%, even though it might be marked 100%, but at the end of the day, it will be graded 60%. You're going to have a mid-semester or mid-term exams, which I would grade 20%, and then assignments and quizzes that I would give to you would also be graded 20%. Now, you realize that the topics have been classified, or the course has been outlined in topics. So, at the end of every topic, we would have some assignments and quizzes, as well as tutorials to go through what we have studied, look at some example questions, and then solve them. So here, the main objective of this course is to provide you students with knowledge on amplifiers, noise and distortion, and then also to introduce you to analog systems and signal generators. So basically, that is what we're hoping to achieve with this course. So let me jump straight into the course outline. We're going to start off with amplifier classifications, where we'll look at the common configurations. We'll also look at operations performed by the type of amplifiers. We'll look at amplifier output properties, and then we'll look at their signal or frequency response. In that case, we'll be looking at audio frequency amplifiers, intermediate frequency amplifiers, radio frequency amplifiers, ultrasonic, wideband, video, DC, and then tuned amplifiers. We would also look at interstage coupling of amplifiers, where we'll look at capacitive coupling. We'll also look at transformer coupled amplifiers. We'll look at direct coupled amplifiers. And then, before we end topic 1, we would have a brief introduction of small signal amplifiers before we move on. So at the end of this topic 1, what we'll be doing is that we're going to be having some assignments and tutorials and quizzes where necessary. So take note of that. As you read, you always prepare for that. Then the next topic we're going to be looking at is going to be power amplifiers. So we'll be looking at their classifications, like the Class A amplifier, the Class B amplifier, Class AB, Class C, and then Class D amplifiers. Then after that, we'll be looking at distortions when it comes to amplifiers. So we'll be looking at amplitude, frequency, phase, and crossover distortions. This is something we'll be doing in Unit 2 or Topic 2. And then from there, we'll jump right into operational amplifiers, which we normally call op-amps. So we'll look at the ideal op-amp and its characteristics. We'll look at the modes of signal operation, the single-ended input, differential input, common mode input, and then common mode rejection ratio, as well as offset null. Now we'll look at negative feedback in operational amplifiers as well as operational amplifier circuits, where in this case we'll be looking at non-inverting amplifiers, voltage follower, which is sometimes called unity gain buffer. We'll look at the inverting amplifier, we'll look at differential amplifier, summing and differentiator and integrator as well. And then you're going to have a case study at the end of this Unit 3. You're going to have to do a case study on some applications of amplifiers. And in addition to that, I'm going to give you a project that doesn't require you to go to the lab, but you would use a software called Multisim to design an application where you would have integrated an operational amplifier. So at that point, I would give you the directives. There will be a material that would outline what you're supposed to be doing with the case study. So when we move on, we'll be moving on to Unit 4, which is active filters. So we'll look at frequency response, and then we'll be looking at filter types: low pass filter, first order low pass, high pass, first order, active high pass filters. We'll look at band pass filters as well as first order, and then we'll also look at notch and band reject filters. And then we'll also look at all pass or phase shift filters. And then we would end with high order filters as well. And then note again, at the end of this topic, we're going to have some tutorials, some assignments, and if possible, a quiz. Then we would also do signal generation and conditioning. So here we're going to be looking at how signals are conditioned. We'll look at analog comparator, we'll look at Smith trigger, and then we'll also look at oscillators, positive feedback, condition for oscillation, RC phase shift oscillator, square wave oscillator, the Wayne bridge oscillator, the triangular or sawtooth or ramp wave generator, and then we'll also look at how we shape waves, as in wave shaping, and then we'll end by looking at the sample and hold theory, or the sample and hold principle. So basically, this is what we're going to be doing in the next 2 months. I'm hoping to end this latest by the end of June or the first or second week in July, so that you can have ample time to prepare for your exams. Now, I would be giving you some materials, some summarized documents that will guide you in your reading, as well as I'm going to be giving you some slides. The slides that I would be using to lecture, they're going to be available to you in both a recorded video form and then a PDF format, so that you'd have enough information. However, I don't expect you to stick solely to the documents or the materials I give you. I expect that you would read very wide, because I am not used to examining students based on materials I give them only. I expect to see you read wider than I have taught you, and that is what is going to distinguish you. So I have provided some reference books, which 6 of them: Electric Circuits, which was authored by James W. Nelson, and then Electronic Circuit Behavior, which was also authored by Daniel L. Metzeger, and then the famous Electronic Devices and Circuit Theory by Robert L. Boylestad and Louis Nashelki. I will upload soft copy of this particular book into your V class, and then I expect that the remaining books you would somehow find them on your own and read them. Since school is currently on recess because of the coronavirus, you probably would have to search online to see if you can find those books. But when you have the chance to go to the library, you should be able to find these books on the shelves of the library. So basically, this is what we're going to be looking at in the next few weeks, or I should say in the next 2.5 months. So since there was no opportunity for you to ask any question concerning this introduction, what you can do is that feel free to send me an email at linusteach@gmail.com, and you can be rest assured that I'll read your email, your questions, your doubts, and respond as well. I will be uploading this introduction on YouTube as well, so you can have access to that YouTube material. So in the comment section in YouTube, what you can also do is that you can go ahead and type your questions or your doubts there, and I'll as well respond to them. So for those who would be watching this on YouTube, I would suggest that you subscribe to my channel, Linus Institute of Technology, so that anytime we post the material, you would get a notification and then follow through with the series of courses or subjects and topics that would be uploading with time. We are not restricted to just electronics and telecommunication. So as students, if you have any topic you would want us to treat, feel free and then send us a mail. We will do an on-demand recording on that topic as well. So guys, with this, I think we'll bring this introductory course, or the introduction to electronics to an end, and hope to see you in the first lecture. Thank you.